In this video, we're going to talk about the working out a formula for relatively simple compounds. And you'll see that there's a little section of the periodic table shown in the video here. And if you look at the red numbers, you'll see the plus and minus numbers there are what we use in a quick way to try and get their formula. Now, they've got a significance that we'll talk about next year, but I want to give you a wee background of where we get those. And then really what the main part of the video is how we use those to get formula. So a formula gives us the number and types of atoms joined together. So we're going to see that different combinations, there's different numbers of atoms that have to join together, and we'll see later on why that is. And we're going to look at the way that these form for relatively simple compounds where two elements are joined. And do you remember that when we join two elements, things like sodium joins to chlorine to make sodium chloride, potassium joins to bromine to make potassium bromide. And we're going to look at what we call the IDE compounds, where two elements have joined and then the compound ends in IDE. Now, the formula of a compound is determined by the way the atoms behave. And the atom's behavior is determined by their electrons. So this is a sort of shrunken version of the periodic table. This is the 20 elements that we have to know the structure of their atoms. And if you look at it, when we put them together in groups, they behave in a similar way. So let's look at this group over here. This is the noble gases. They're the ones that don't want to react with anything else. And if you look at it, you see they've got a full outer shell of electrons. Now, because they've got a full outer shell of electrons, they don't want to combine with anything. So you're going to see the number we put beside them is 0, and we never have to work out a formula for them because they don't react with anything. As far as you're concerned, up to GCSE, they have no reactions whatsoever. The other elements, well, it depends on the combination of them. These elements here on the left-hand side tend to react with these ones on the right-hand side. So you'll see, for example, sodium will react with chlorine, and that makes sodium chloride. Now, why do they react together? Well, if you look at it, sodium has got one electron in its outer shell. It really wants to get a full outer shell. It wants to be a bit like a noble gas. It wants to have a full outer shell. So it can lose that electron. And we're going to signify that by putting +1. Whenever it loses that electron, it ends up positive, as it was called a positive ion. So it's got a charge of +1. And you see that all the elements in this group are the same. They've all got one electron in their outer shell. So they're all +1. So we're going to signal that by putting a +1 above them. Hydrogen's quite often put into that group because it's got one electron and it wants to lose it quite often, and it's +1. This block here all want to lose 2 electrons. So above that we put +2. And if we keep going across the periodic table, this group want to lose 3. This group is a sort of switch over. They could lose 4. That would give them an outer shell, but that would be full because they would still have the shell underneath it full. Or they could gain 4. This group here could gain 3. And you'll see then that what we've put above that, because they gain 3 electrons, they're different from these ones that lose 3 electrons. So we put a +3 above this group here, the ones that lose 3 electrons. We put a -3 above this group, the ones that gain 3 electrons. This group we put a -2 above because they want to gain 2 electrons. This we want to put a -1 above because they want to gain 1. So really that's why the atoms combine together, and they combine in different ways. But what we're going to show you is how you can use those plus and minus numbers to really work out their formula. Now, their formula is determined by their position in the periodic table, because their position in the periodic table has been set by the structure that they have in terms of electrons. So we will take this shortened version of it, and you'll see those plus and minus numbers there. And as we need them, we'll talk about those. Now, this block in the middle, when it comes to GCSE, we never have to work out the electrons for these elements here. So what they'll do is they'll tell you how these elements will behave. So you'll see if we've got a compound, for example, containing copper, it'll say things like copper 2 oxide. And what the 2 tells us is that the number we're going to use with it is +2. So these plus and minus numbers, we will learn their significance next year, but we can still work out formula with them. So let's do that. Right, so lithium chloride is the first compound we'll work with. So lithium chloride, so it contains lithium and chlorine. Now what we want to find out is how many atoms of lithium, Li, combine with atoms of chlorine. So the symbol for a lithium atom is Li, the symbol for a chlorine atom is Cl. Now, how do they behave? Well, lithium loses 1 electron, it's +1. So we're going to take that +1 and put it beside it. So we'll put the +1 there. Chlorine, it wants to gain 1 electron, so we put a -1 beside it. And what that really signals is that lithium can lose 1 electron, chlorine can gain it, and they've basically reacted together like that. And that's them finished. They only need 1 atom of lithium, 1 atom of chlorine. At a simple level, if you look at the numbers, the plus and minus numbers, and if the plus and minus numbers cancel out or they balance, then that's it. You've got the formula worked out. So lithium's +1, chlorine's -1. We put them together and the formula becomes LiCl. So that's the formula for lithium chloride. So that tells us 1 lithium atom combines with 1 chlorine atom, and lithium chloride's LiCl. Second example is calcium oxide. Now, to work out the formula for calcium oxide, we take atoms of calcium, Ca, we combine it with atoms of oxygen, O. So the symbol for calcium atom, Ca, oxygen, O. Numbers, calcium has got a +2 above it, so we put +2. Oxygen's got a -2 above it, -2. Now, those basically cancel out. And when it comes to electrons, we'll see later on that calcium has lost 2 electrons, oxygen has gained 2, so they cancel out. So we simply need 1 atom of calcium to combine with 1 atom of oxygen. So our formula for calcium oxide is CaO. Next one, iron 3 chloride. So this is iron, which is over here, combining with chlorine. So let's put it down. So the symbol for iron Fe, symbol for chlorine Cl. Now, how does iron behave? Well, we haven't got anything above the column there. So it says to look for the Roman numeral. Well, the Roman numeral there is 3. So that tells us to use +3 with iron. And what that really means is iron wants to lose 3 electrons. Chlorine is Cl -1. So it's -1. We'll put that underneath it. Now, what does that mean? Well, that means iron wants to lose 3 electrons, chlorine only wants to gain 1. So when iron combines with chlorine, if those atoms are going to combine in such a way that they get full outer shells, we can't combine simply 1 iron with 1 chlorine. So what we have to do is we have to get it to lose 3 and this to gain 3. Well, each of those can only gain 1. So let's get another chlorine. Well, it can gain another 1, so that's now lost 3. This is gained 2. Okay, so that still doesn't quite work out. And then let's put another one there. So this has now lost 3 electrons. Each of these has gained 1. And now they balance out. So again, the easy way to think of it without having to think about electrons is think that this is +3. And now we've got -1, -1, -1. So those all together make -3. So the pluses and minuses cancel out. Now to get the pluses and minuses to cancel out, we had to use 1 iron and 3 chlorines. So the formula becomes FeCl3. Next one, lithium oxide. Now for lithium oxide to work out its formula, we take lithium here, oxygen here. So there's the symbol for a lithium atom, there's the symbol for an oxygen atom. Lithium is in group 1 +1, oxygen's in group 6 -2. And again, going back to what that really means, this wants to lose 1 electron. So this wants to lose 1, this wants to gain 2. So 1 atom of lithium and 1 atom of oxygen aren't going to work together because this only wants to lose 1, but this needs to gain 2. So for this to gain 2, we actually need 2 lithiums. Now, again, if you look at the simple level, the total number this side is +2, the number this side is -2, they've cancelled out. Now, to do that, we've had to use 2 atoms of lithium to combine with 1 atom of oxygen, so the formula for lithium oxide is going to be Li2O. The next one, magnesium sulfide. So, Mg is magnesium, so it's here. Sulfide means it's combining with sulfur, which is over here, S. Now the numbers then, magnesium's group 2, so it's going to be +2. Sulfur is over here, and with this group, -2. So this has balanced out, hasn't it? This has lost 2 electrons, this has gained 2 electrons. So again, they only need 1 atom of each to work. So 1 magnesium combines with 1 sulfur, and the formula is then MgS. And next one, iron 3 sulfide. So iron 3 sulfide, Fe, which is here, iron, Fe. Sulfide means sulfur, S. Now let's put the numbers in. So iron is plus 3, so we put that underneath it. Sulfur, so the plus 3, we should say, came from that. Is that right? The Roman numeral was 3, so it's plus 3. Sulfur is here, so it's minus 2. So what did we have to do? Now, this time the numbers aren't balancing out. Plus 3, minus 2. And in fact, they're going to be a wee bit awkward. So if we put another sulfur there, that's minus 4. So that's really losing 3 electrons. That needs to gain 4. That doesn't work. Okay, so let's put another sulfur. Now, what have we got? We've got minus 2, minus 2, minus 2, minus 6 with 3 of them, so minus 6. The iron has lost 3. So if we had another iron. Now, again, the easy way to think of that is think of the lowest common multiples. The lowest common multiple of 2 and 3 is 6. So to get minus 6 on this side, we've had to use 3 sulfurs. To get plus 6 on this side, we've had to use 2 iron. So the iron has really lost 3 electrons. This one's lost 3 electrons, so that's losing 6 electrons in total. And this has gained 6 electrons in total. Now, to do that, we had to use 2 iron and 3 sulfur. So the formula then would be Fe2, 2 iron, 1, 2, 3 sulfur, S3. So Fe2, S3. And our final example, aluminium oxide. So aluminium is here, Al plus 3. Oxygen is here, O minus 2. So we'll put our numbers there. So this is the same as the last one, isn't it? This is plus 3 minus 2. So let's go for the lowest common multiple, which would be 6. 3 and 2 would be 6. So to get 6, we need to use 3 oxygen atoms. And that's them gaining 6 electrons in total. We need to have 2 aluminium, that's them losing 6 electrons in total. So to do that, we had to use 2 aluminium and 3 oxygens. So the formula is Al2O3. Okay, so your worksheet, I'll leave this screen up. For those that can't print off the worksheet, I will run through the video. And what we've done is I've put little screenshots of each row, and when you're ready to do it, what you can do is you can pause it at each row, you can write out your name and then work out the formula, and then run the video on slightly and I'll have the next row up and so on. For those of you that have the worksheet and have got printed off, then all you simply have to do is, if you want, keep that screen up to get the plus and minus numbers and then work out the formulas in the rows underneath it. So there's the first one, so you can pause and try that if you want. There's the second row. There's the third row. Fourth row. Fifth row. And sixth row.